Part 1. Introduction. Ever wondered how your smartphone can recognize your face, or how self-driving cars navigate complex environments? The answer lies in computer vision, a field of artificial intelligence that allows computers to see and understand the world around them. A fundamental aspect of computer vision is geometry, which provides the mathematical tools to describe and analyze the 3D world from 2D images. Part 2. The basics of computer vision. Computer vision is all about teaching computers to interpret and understand visual information from the real world. This involves tasks like image classification, object detection, and image segmentation. To achieve these tasks, computers need to understand the geometric relationships between objects in a scene. Part 3. Why geometry matters. Geometry is the language of shape and space. In computer vision, it helps us understand the 3D structure of objects, their relative positions, and their motion. For example, to recognize a face, a computer needs to understand the geometric relationships between the eyes, nose, and mouth. Part 4. Key concepts in computer vision geometry. Some key concepts in computer vision geometry include 1. Camera calibration. Understanding the intrinsic and extrinsic parameters of a camera to accurately reconstruct 3D scenes from 2D images. 2. Feature detection and matching. Finding distinctive points or regions in images and matching them across multiple views. 3. Structure from motion. Recovering 3D structure from a sequence of 2D images. 4. Epipolar geometry. Understanding the geometric relationship between corresponding points in two images of the same scene. Part 5. Applications of computer vision geometry. Computer vision geometry has numerous applications in various fields. 1. Robotics, enabling robots to navigate complex environments and interact with objects. 2. Augmented reality, creating immersive experiences by overlaying virtual objects onto the real world. 3. Self-driving cars, allowing vehicles to perceive their surroundings and make autonomous decisions. 4. Medical imaging, analyzing medical images for diagnosis and treatment planning. Part 6. Challenges in computer vision geometry. Despite significant advancements, computer vision geometry still faces challenges. These include dealing with varying lighting conditions, occlusion, and the complexity of real-world scenes. Additionally, robust algorithms are needed to handle real-time applications. Part 7. The future of computer vision geometry. The future of computer vision geometry is promising. With the advancements in deep learning and the availability of large datasets, we can expect to see even more sophisticated and accurate computer vision systems. Imagine a future where computers can fully understand and interact with the visual world just like humans.